Good morning. Thank you very much for your talk. It was very interesting. And I was particularly interested in costs and how you calculate the costs of the colony losses. This is the first, one of the questions. I guess, I don't know, but I guess that you simply applied the cost of replacement of the beehive. And the other question was if you you think that your results can be applied to the evaluation of losses on production, to the assessment of losses on production.
For honey production.
Oh, honey production, exactly.
So it was a question of a river, so I have the answer. No, we did not added this honey production as an impact because in France, beekeepers are harvesting the honey before hornet impact. So usually they are harvesting in July, August, and the predation, the impact of the predation arrive just at the end of August until November. So we did not include the honey production as an impact, a direct impact of the hornet. It's for that we only focused on colony replacement. It was, the memory, it was 200 euros per colony to replace the colony that died due to hornet.
More questions? We have.
Thanks, Fabrice. Very interesting talk. The first one is related to your own question about are personal actions of beekeepers connected to science recommendations. Basically, you said no. No, at the end of all this process is this huge wall between science and what beekeepers do. And you say communication, but do you think there are other ways to break this wall from both parts? Because this is a very important task for us now, as a scientist and as a society, because we are saying some things, but these things are not being heard or not being understood, and I want to know your opinion about that.
It's not an easy question, but very good question. I think it's a very specific, topic with Asian hornet and beekeepers, because they, from my point of view, it's the only or the single pressure that is very observable in the field for the beekeepers. When pesticide is not visible, they cannot observe pesticides. Therefore, it's very complicated. Hornets, when they visit the apiaries, they observe hornets. Even if it's a single hornet, they are very scared about this impact, and they overestimated the impacts. Most of the time, they overestimate the impact because it's very visible. So it's not easy to communicate and to explain. No, it doesn't care. It's a single hornet. Vespa Crabro do the same, and yeah, we do. In the discussion of this paper, we were very careful with why the recommendation or the action is disconnected to the recommendation from science. And we recommended to see what's happened on other biological invasion processes that are not so sensible. Like beekeepers, they love their bees. So I think I will not answer correctly to your question. It's too difficult, but just we have to take in account what was done for other topics before, and other topics that are less challenging or less sensible. I have no example in mind, but plants or that people that they are not so
For instance, regarding trapping, this is very controversial method. But is there any assessment of how effective is trapping in France?
Yes, yeah. There is one paper or two, I think, done in France that estimated the efficiency of the traps, and it's not efficient to control the populations. At population scale, it's totally inefficient. And for the apiary, it's also inefficient. So it's like if you have traps, you are not reducing the loads. You can collect, and I have a beekeeper that called me 2 months ago. He collected about 200 hornets per day in a trap, but he did not reduce the loads after 2 months. It was exactly the same. So it's inefficient. And this comes from beekeeper observation. So they know that it's not efficient. They are doing that because they don't know what to do, and they want to do something. And I think we don't know what to do as scientists. Also, we cannot recommend some things. I just recommend sometimes to don't use because it's not needed. But when it's needed, I don't have any recommendation what to use. It's always trap because we have no other techniques available to date.
One last comment, may I? In the plots with the frequency of presence of the different group of insects in the traps, I have one comment, because it is not the same to have the presence of the hornet or wasps or social insects against other non-social insects. It doesn't, ecologically, biologically, these are very different things. To compare the presence of one individual of one colony and one individual that it is necessary for the survival of the species. So it is very tricky to work with just presence and absence.
Yeah, I
be
fully
careful
agree.
with that.
Yeah, I fully agree. I fully agree. It was just we had the data on the quantity because all beekeepers were invited to count the number of diptera they observe during a day. They observe in a trap, but we did not use that because it was a bias, or an observer bias. So we only use presence absence, but yes, of course, it's not the same. But it's still a presence. It's still non-targeted species that are trapped by a trap. So it's still an impact from beekeepers to biodiversity. So, but I agree. Yeah, I agree.
Okay, thank you. Good presentation. And in the direction of that we have talked until now, I think, of course, there is a question about the personal actions of beekeepers connected to the science recommendations, but maybe because they want and we haven't recommendations in specific to reduce the pressure of the pest. This is the question. They want, and they want us. But sometimes we are not enough in the real time to answer. And that's why this kind of information, communication, and the Congress are very important. After them, we go to our countries and make the things go on, because this information is very important, not only in the science, in the world of science, but in the real world, in the practical world. And they are very interesting in know more things to do, But really, the point is what we are talking about. To detect the nets is very difficult, and we haven't knowledge until now to be effective early. And the beekeeper, when see hornets behind, what he can do, it's very difficult.
Mm-hmm.
We can talk about, and we need more results as we are talking in this morning. Thank you very much.
Yeah, thanks.
It's a commentary, of course.
Yeah, but I fully agree. Yes, it's and in this case we only compare when the Asian hornet is established what to do. I think we can still recommend some techniques to control the spread when the hornet is still not present, and so just killing the new nests. But when the population is established, what to do, how to help the beekeepers, and this is very challenging. And now it's all France is in this situation. And the beekeepers still they want to do some things, and we are not able to help them. Clearly, it's that we are not able to help them, and so they are using other things like fipronil and what else.
More questions?
Hi, Fabrice. It's the whole area of sort of science communication is obviously a fascinating area, potentially an area where sort of science has failed. But I imagine this will be a debate that will be ongoing beyond this presentation. I believe Helen Roy is going to be talking about science communication next as well. So I'd like to actually bring a question back to some of the earlier work where, interestingly, you mentioned you also had Varroa included in the Behave model. And something I've picked up from surveys done is that beekeepers still regard Varroa as a more significant pest than the hornet in most cases. Obviously, there will be individual variations. So I was wondering actually whether your modeling did actually sort of demonstrate whether the presence of the hornet impacted on Varroa problems, or in a positive or a negative way. And one of the things that obviously is a challenge is in assessing the mortality of a colony. What was the cause of it? Beekeepers will be aware of hornets hawking outside of their hives, and they could easily sort of also assess Varroa levels, but it's having delayed consequences often makes it difficult to attribute whether it was due to one or the other. And I wonder whether you have comments, particularly from the modeling work that you did.
So yes, we included Varroa because it was very common to all the beehives contain Varroa now, so it was necessary to include that in the model. And I also explore in the data if it's Varroa that could explain the collapse of the colony during the winter, or if it's the Asian hornet. And Varroa did not explain the mortality. It's so in the processes, in the mechanical way. So it was very linked to the hornets, what I implemented as a hornet impact, so this foraging paralysis and homing failures that leads to a disturbance in the colony, the dynamic in the processes. And also what I did not present it because it was too much, but we also did some exploration of what could be the early warning signs for beekeepers to prevent the colony collapse. So based on Behave, exploring okay, if there's if we can have 2 months before the collapse an indicator that could prevent the collapse of the colony. And we found some like the weight of the colony or the quantity of honey. And this is something that beekeepers are using, tracking during the start of the winter. If the colony is still the trade-off between the quantity of adult population and honey reserve is still a good balance or not. So if there is enough resources for the adult bees. And this was the best recommendation to open the hive before wintering and to control this balance. If you have enough honey for your beehive, if not, you have to feed them to prevent the winter collapse. I don't know if I answered correctly. And this was more or less the idea, yes.
So first of all, thank you so much, Fabrice. Very interesting.
Thank you very much.
So.